Okay, so this is going to be our day 4. Uh, well, let me back up. This is going to be our first video of 4 videos for day 4 of Unit 4. That's a whole bunch of 4s. In Algebra 2, there's a different number. So, in this first video, we're going to just briefly discuss how transformations work on logarithmic functions. Okay, so in the previous lesson, we talked about logarithms and whatnot. Now we're talking about logarithmic functions. Um, Not a whole lot different than anything we've ever seen. You can already probably guess what A does. Okay, so A is obviously going to be our vertical stretch or shrink, right? And you all also can probably already guess that if A is, we'll say if A is negative, right, then we are reflecting across the x-axis. Okay, let's see here. B is our base, right? And we'll always assume B is going to be greater than 0, just like we did with with exponential bases. Except we don't quite have the same concept of growth and decay that we do with uh, exponents. So I guess you could say that you have logarithmic growth and decay, but we're not going to go that far into that. I just need you to know that B obviously is the base. We talked about that in the previous lesson, though. Okay. What do you guys think C does? Well, no duh. That's our horizontal shift. Okay, that's our horizontal shift. And now this is something different for logarithmic functions as opposed to exponential functions. On logarithmic functions, right, we don't have a horizontal asymptote, we have a vertical asymptote. So this also shifts vertical asymptote. Okay, and we'll have a graphic for that here in a second. You can already see the Desmos link underneath. Okay, and of course D, what do you think D does? That shifts us up or down, so that's a vertical shift. Can't spell. Okay, vertical shift, which is up, down. And just in case you're having a brain fart, I'll go ahead and write this out. Horizontal shift, that means right or left. Okay, so now let's look at what Desmos has to offer us. Okay, so here we have just a parent logarithmic function where the base we see is equal to 10. So what we've got is log base 10, right? And when I mess with the a value, right, we see we have vertical stretch, or if I'm in between 0 and 1, we have vertical shrink. And if a is negative, we see we get reflected across the x-axis. Okay, so I'm going to reset that back to 1. Okay, so now let's look at what C does. And real fast, B doesn't really do anything. Okay, remember, B for us is always positive. And we see that we do have some things happen as B approaches 1, right? It gets taller and taller and taller. And then it just becomes non-existent. And then when we go in between 0 and 1, we see that we have something resembling exponential decay, except really topsy-turvy. And like I said, we're not going to get into all that. Okay, so we're just going to leave B as 10, okay, because we're already pretty used to seeing that. Okay, so let's talk about C. Well, we see, what does C do? That shifts us right or left, which means our asymptote, right, our vertical asymptote now is shifting right or left. Okay, so if I go ahead and just come down here and say y equals c, that's not what I meant, x equals c. Okay, as I move this, we see our vertical asymptote is shifting right along with us. Okay, and then of course d makes us just move up or down. Okay, so that does it for this video. That's how the transformations work for logarithmic functions. If you have any questions about any of this, shoot me an email. Otherwise, you know where to find me. Goodbye.